Alright, so let's finish up talking about Saturn. Okay, so we left off last time talking about the rings and all the characteristics of the rings. So how might those rings have been formed? Well, there's this thing called the Roche limit, and it's a distance limit, and it's a distance in which you can reach tidal stability. In other words, if a body is inside that distance, tidal forces rip the body apart, and if a body is outside the distance, the forces are not strong enough to rip it apart, and it keeps its shape. So looking at this picture here, this satellite is far enough outside the limit that there's barely any tidal forces. What tidal forces are? It's when uh, you pull on one side more strongly than you pull on the other side, so it stretches it out. Uh, that's just and that's more noticeable the closer the satellite gets. When you're this far out, the forces aren't strong enough to really stretch you out. But as you get closer and closer, the difference between this force on this side of you and this force on this side of you becomes bigger and bigger, and you start getting stretched out. This is really close, and it's really stretched out here. And then if you become inside the limit, which is this outer circle, you can see that what used to be a moon here is all broken up, and then the rings form that way. So if a satellite's not in too close, if the satellite is in too close, then the tidal forces will break that satellite up. A moon-sized object roughly 250 kilometers in diameter would be big enough to have formed the rings around Saturn. So all of the rings you see around Saturn could have come about from a smallish moon, actually. 250 kilometers in size is not a huge moon. So, but even though it looks like a lot of material, the ring is so thin that it just doesn't really. It's not as much as it appears. And here you see the outer planets. I haven't talked about Uranus or Neptune yet, but all these outer planets have rings. Here you can see the Roche limit, and the rings are all inside that Roche limit. The only exception is this interesting Adam's ring, which is outside. But for all the other rings, they're all well within the Roche limit. Saturn, they're spread out almost the entire distance from the surface of the planet, which is at 1 radii, to the Roche limit. Jupiter's ring is closer to the planet. Uranus's are kind of in the middle, all squished together here. And Neptune's few rings are kind of farther out towards the outer parts of the limit. And we couldn't really see all this detail in these rings before sending Voyager out to Saturn. We just didn't have telescopes powerful enough to see all those. But Voyager allowed us to see a lot more detail in the rings. You can see it's really actually just a lot of smaller rings all clumped together. And when you're far enough away, they look just like one big ring. So Voyager revealed the D ring, which is a small ring inside the C ring, the E ring, located beyond the A ring, formed by debris from Enceladus. Enceladus has tidal forces acting on it, causing it to erupt, and that material escapes the moon's gravitational pull and gets formed into a ring. There's the F ring, found after the E ring, and the 1 ring. One ring to rule them all. One ring to find them. Blah blah blah. Here's a close-up of the Cassini division, which looks like a gap in the rings, but it's not really completely empty. It has a few little tiny ringlets and gaps. And this division is caused by the gravitational tug of one of Saturn's innermost moons, the Mimas. The F ring, you can see here, is made up of several really thin strands of ring material, all kind of braided together. And this ring is formed, its shape is formed by 2 shepherding satellites. And you can actually see in this picture that ring, and then one of the satellites causing the shepherding. So here you got the two moons, Pandora and Prometheus, and here's that ring. And each moon is pretty small, about 100 kilometers in diameter, and they play this tug of war to keep this ring in place. This moon pulls out that way, this moon pulls out that way, and the 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 effect of that is not to spread the ring out, but is actually to kind of shepherd it and keep it in. And you can pause in this picture and take a look at it. It's showing again the kind of the reaction. Here's one shepherding moon, the outer moon. Here's the inner shepherding moon, and but you don't need to know that at this much detail. This is well beyond the scope of the class. All right, so that's the rings. Now, what about the moons of Saturn? Being so far out, it's really cold out there. Most of the moons are covered in ice and snow. Saturn has 6 medium-sized moons. Hold on a sec here. 6 medium-sized moons. Diameter is about 400 to 500 kilometers. And it has a really big moon, the second largest moon in the solar system, called Titan. It's the second largest behind Jupiter's Ganymede. Currently, we've found about 62 moons around Saturn, with probably more to follow. Although they're tiny, tiny. That's why it's hard to find them. Here's a list of large moons, 10 kilometers in diameter or larger. We got Titan, 5150 kilometers in diameter. The next biggest is Rhea, quite a bit smaller. So you can see really just one major moon and then a bunch of kind of medium-sized moons. Titan was discovered a while back because it's pretty big, back in the 1600s. And both the Voyager probes were actually originally scheduled to just go to each planet, Jupiter, Saturn, Uranus, and Neptune, and study them like that. But as we got closer to Saturn and closer to Titan, we realized, well, why don't we risk it? We'll just let Voyager 2 go to the outer planets and get a really good look. You know, the orbit is just right, so that if we tweaked it a little bit, we could actually get really close to Titan. And so that's what we did, and we sacrificed, you know, the 2 outer planets. Luckily, Voyager 2 was able to successfully reach them, and we also got a closer look at Titan because of it. More recently, the Cassini orbiter has sent a probe onto Titan, actually landed on Titan. It's pretty awesome. Launched Cassini in '97, took quite a few years to get there. It's still orbiting and collecting data, by the way. And the Huygens probe in 2005 descended down onto Titan, and it took atmospheric readings on the way down, and also landed, kind of bounced up and down. So we think it landed on a jello-like substance. And on the way down, it took some data of the atmosphere, and this is the best data we have of the atmosphere so far. Temperature on the way down, getting hotter, 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 hotter. Actually, sorry, colder, 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 and then hotter, hotter, hotter. Only one turn in temperature here, but there's a lot of haze in the atmosphere. It's a very thick, dense atmosphere. It's actually denser than our atmosphere. It's a lot like our atmosphere in many ways. It's mostly nitrogen. Our atmosphere is mostly nitrogen. But what's different, in a lot of argon, we have a lot of argon, but what's really different is we have a lot of oxygen in our atmosphere. Not much oxygen in this atmosphere. Surface temperature, extremely cold, 94 Kelvin. That's way, way below zero. And it's thought that at this temperature, methane can condense and become a liquid, and so we might get some methane rain. Here's another picture of the haze layers, smog-like layers, smog, and some other pictures of the moons, smaller moons. Rhea is the second largest moon, followed by Iapetus. This is our moon in size comparison, so these moons are a little bit smaller than our moon. If they were the same distance away in our sky, they would look this big. Of course, we got the Death Star here. Mimas is the one that makes the that gap in the rings, right? We talked about. So the rings are these moons are mostly composed of rock and water ice. Rhea, the second largest moon of Saturn, is about 1/30th the mass of our moon. And because it's so cold out there, the ice actually acts like rock, and so when you have impact craters on it, it looks like the impacts were hitting rock and not ice. Mimas again causes the Cassini gap. And another picture of Rhea showing the craters that look like you're hitting rock. Another moon, Enceladus. This is covered in ice and reflects almost all of the sunlight it receives. Very high albedo is the word for it. Geysers on Enceladus spew H2O into the atmosphere, and some of it freezes instantly. Well, it does freeze instantly, but some of it sinks back down to the moon. A lot of it goes out into space and orbits, and feeds the E-ring around Saturn. I think I'm going to stop there. Another picture of Saturn. Don't really need to worry about that too much. Yeah, so that's Saturn. And we're done this unit. Alright, not too shabby. Talk to you later.